Have you ever heard of a child who learned to calculate before he could even speak? A mind so brilliant, he was correcting his father's payroll accounts before he even started primary school. This isn't a fairy tale. This is the story of Carl Friedrich Gauss, born in 1777 in Brunswick, Germany, into a poor, uneducated family. His father, a hard-working man, was often skeptical, almost fearful, of his son's inexplicable genius. The first legendary tale of Gauss's brilliance happened when he was just 10. His schoolmaster, desperate for a moment of peace, gave his restless class an impossible task: add all the numbers from 1 to 100. As the other students began the long, tedious work of addition, young Gauss simply wrote 5050 on his slate and handed it in. How he hadn't added them one by one. Instead, he saw a hidden pattern. He realized he could pair the numbers. 1 plus 100 is 101, 2 plus 99 is 101, and so on. There were 50 such pairs. 50 times 101 is 5050. This self-discovered formula for an arithmetic series was a stunning glimpse into a mind that could see profound order where everyone else saw only chaos. It was the first sign that this boy was destined to change the world. Gauss's extraordinary genius almost withered away in poverty, but a pivotal moment changed everything. At the age of 14, he was introduced to the Duke of Brunswick. The Duke, a man of vision, saw the incredible potential in the boy and agreed to fund his education, sending him to the prestigious University of Göttingen. It was here that Gauss's mind truly ignited. During these formative years, he made 2 breakthroughs that would echo through the halls of mathematics forever. First, at just 18 years old, he solved a puzzle that had baffled mathematicians for over 2,000 years. Using only a compass and a straight edge, he figured out how to construct a regular 17-sided polygon. This wasn't just a party trick. It proved that the world of geometric constructions was far vaster and more mysterious than anyone had ever imagined. His second major achievement came in his doctoral dissertation. He delivered the fundamental theorem of algebra, a cornerstone of mathematics that proves every polynomial equation has at least one root. These early triumphs didn't just earn him respect, they crowned him a sovereign in the world of numbers. It was at this point he dedicated his life to his passion, famously declaring, "Mathematics is the queen of the sciences." But Gauss's greatest moment of public fame didn't come from abstract theory. It came from the stars. On January 1, 1801, astronomers discovered a new celestial body, a small planet they named Ceres, but their excitement quickly turned to panic. Ceres was tiny, its path was short, and it soon vanished behind the sun. With so little data, astronomers feared it was lost forever, a cosmic ghost. The challenge was immense. How could you predict an entire orbit from just a few fleeting observations? This is where Gauss stepped in. Years earlier, in his private notes, he had developed a revolutionary new technique for calculating orbits from minimal data, the method of least squares. Now, he had a chance to put it to the test. He worked feverishly for months, poring over complex calculations, mapping the invisible trajectory of the lost planetoid. Finally, he announced his results, pointing to a specific spot in the night sky. Across Europe, astronomers aimed their telescopes at his predicted location. And there it was. Ceres, right where Gauss said it would be. This incredible feat of celestial rescue made him an overnight celebrity. It secured his position as director of the Göttingen Observatory, and, more importantly, it proved that his abstract mathematical tools had the power to describe the real, physical universe. Gauss's career from that point on was an exploration of nearly every corner of mathematics and physics. His work on differential geometry laid the essential groundwork for Einstein's theory of relativity. In partnership with Wilhelm Weber, he delved into electromagnetism, even building one of the world's first electromagnetic telegraphs. He also gave us one of the most fundamental concepts in statistics, the normal distribution, better known as the bell curve. This elegant curve governs everything from the distribution of human heights to errors in scientific measurement. A universal pattern in the randomness of life. Yet for all his public achievements, the vast majority of Gauss's greatest discoveries were hidden away in his private notebooks. He lived by a strict motto, "Poca, sed matura," which means few, but ripe. He refused to publish his work until he believed it was absolutely perfect and complete, valuing scientific integrity over the rush for recognition. He was a solitary genius, content to decipher the universe's secret language on his own terms. When Carl Friedrich Gauss died in 1855, he left behind a legacy of rigor, discipline, and visionary insight that remains the gold standard in science. He wasn't just a mathematician. He was the Prince of Mathematicians, a title he had truly earned. If you could ask Gauss about any unsolved problem in math today, which one would you choose? Let us know in the comments below. If this story of the ultimate mathematical mind fascinated you, hit that like button and subscribe for more deep dives into the figures who unlocked the secrets of our universe. Thanks for watching.